Hello and welcome to the fifth video on calculus. In this video, we are going to discuss relations. So let's get started with the definition of a relation. So let's first say that uh, there are two sets A and B. Then the binary relation from A to B is the subset of the Cartesian product of A and B. So let me write it down. Let me write the definition down. Then I will explain the definition in more simple terms. The binary relation from A to B is a subset. Let me write it again. Is a subset of the Cartesian product of A and B. So the binary relation from A to B is a subset of the Cartesian product of A and B. So what is the Cartesian product of A and B? Well, the Cartesian product of A and B is a set which contains all the ordered pairs such that each in each ordered pair the first element is from A and the second element is from B. Let me show you an example. So let me say that there is a set A which is A, B and C, and there is a set B which is X, Y and Z. So the Cartesian product of A and B is a set which contains all the pairs where the first element is from A, where in each ordered pair the first element is from A and the second element is from B. It's kind of like AX is a pair and AY is a pair and AZ is a pair, and then BX and BY and so on. Like A comma X is a pair, and it is important to note that the first element is always from A and the second element is always from B when we are defining a relation from A to B. If we are defining a relation from B to A, then it would be inverse, right? So the first element is A comma X, then A comma Y, then A Z, then BX, BY and BZ, and CX and CY and CZ. So this is the Cartesian product of A and B. It's just like getting all the pairs which have the elements from A and B, that the first element is from A and the second element is from B, and this is the Cartesian product. This big set is the Cartesian product, and a relation from A to B, a binary relation from A to B, is just a subset of this Cartesian product. Okay, so that is the definition of a binary relation. So let me move on to the details of a relation. So when we say that an element from A is related to an element in B, then we denote that by A R B, where R is the relation, and A and B are the elements which are taking the relation of, right? This denotes that an ordered pair A B belongs to the relation. Now what we mean by belongs to the relation is that the relation is also a set which contains which is a subset of this Cartesian product here, this Cartesian product. So when we say that A or B, we are meaning that the ordered pair A and B is a subset of the relation, right? The relation from A to B. And if the if the ordered pair A and B does not belong to the relation, then we denote it like this. So A is not related to B, and when A is related to B, we say that A is related to B by R, by the relation R. Okay, let's move on to an example now. uh, so let me say that there is a set A which consists of students, let's name them A, B and C, and there is a set B which consists of some subjects like math, science, and let's name arts. Okay, these are the sets. Okay, now what we know in the question is that A is taking math and science, B is taking science, only science, and C is taking math and arts. Now, the what we need to find in this question is we need to write the relation from A to B, given this information that A is taking math and science, B is taking science, and C is taking math and arts. Right? Relation R from A to B, where R consists of A, B, ordered pairs A, B, such that student A studies subject in B, subject in B. So we need to write this relation which consists of the ordered pairs. Now how we the way we need to write the ordered pairs from A and B is we need to write elements here in A and then relate them to the elements in the set B through this relation, which says that we need to find the ordered pairs such that the student A studies subject B. But we know that students in here in A, B and C study these subjects respectively, so we can directly write a relation, right? So here we can take A from set A, and we know that studies math through the relation which we are given, and A also studies science. Now note that we are writing A math and A science because it was given in the question that we need to write only the ordered pairs where the student A studies a subject in B. So the student A here studies math and the student A studies science here. So we are writing these pairs particularly from the Cartesian set of A and B. And so now A studies math and A studies science. That's over. Now let's move on to B. B studies only science, right? So scroll it. Yes. Now C studies math and arts. So we can write C math and C arts. Where so this is the relation from A to B. The relation is that the students in A study the subjects in B. So the student A here studies math, student A also studies science, B studies science, C studies math, and C studies arts. So we have defined this relation in this particular way. And now let's move on to another concept. It is kind of similar concept, which is relation on a set. So relation on a set. Now what we do here is, let me take a set A, and in this we take the set A and relate it to A itself. Okay, so let if the element in if the set contains the elements 1, 2 and 3, and since again we are relating the set A to the set A which contains the elements 1, 2 and 3, we are relating these two sets, which is perfectly possible, right? So we can relate a set to itself, because we can find the Cartesian product of this set and this set, right? So then why can't we find a relation from a set to itself, right? So this is the concept of relation on a set, which says that we take a set, the relation on a set can be defined as it's a subset of the Cartesian product of set A and set A, right? So that is how we can define relation on a set. Let me do an example now. Write the ordered pairs of the relation R equals AB, which is an ordered pair which satisfies the condition such that A plus B is greater than or equal to 7. So this is the condition that we have they have given in the question. This is the relation, and we have to do this for the set A, 2, 3, 4 and 5. Okay, so basically we need to take the set A and relate it to the itself, and we need to write the ordered pairs of these two sets such that the elements in ordered pair A, B satisfy the condition A plus B greater than or equal to 7. So the relation would be the ordered pairs from here and here, which satisfies this condition. So if you take an element from here A and an element from here, in this which is the same set, suppose let's take the element 2 from here and 2 from here. If we take the sets 2 and 2, will it satisfy the condition that is given here, which is A plus B greater than or equal to 7? Clearly not, right? So because 2 plus 2 adds up to 4, which is less than or equal to 7. So we can't include this particular ordered pair in this relation, right? Let's check for other ordered pairs. Can we take 2 and 3 here, 2 from here and 3? No, right? Because it adds up to 5, and which is less than 7. We can't take 2, 4 either, because it adds up to 6, which is again less than or equal less than 7. But we can take 2 and 5, because if we take 2 and 5, the sum of 2 and 5 is going to be 7, which satisfies the condition greater than or equal to 7, right? So if we take 2 and 5, the sum will be 7, which satisfies this given condition. Now we have taken all the possible ordered pairs from 2 here. Now let's go on with 3. So if you take 3 here, and let's start from here 2. If you take 3 and 2, will it satisfy the given condition, that is greater than or equal to 7? No, right? Because it adds up to 5. If you take 3 and 3, it will again not satisfy. If you take 3 and 4, it will add up to 7, which satisfies the given condition that A plus B should be greater than or equal to 7. So we can take 3 4. We can also take 3 5 because the sum adds up to 8, which is clearly greater than or equal to 7. We can take 4. We cannot take 4 2 here because the sum is 6. We can take 4 3 since the sum is 7. We can take 4 4 and we can take 4 5. Now let's move to 5. From 5 we can take 5 2. We can take 5 3. We can take 5 4. We can also take 5 and 5 because when we take 5 and here, when we take 5 here and see the sum when added with these elements, it's in every case it's going to be greater than or equal to 7, right? So these are all the ordered pairs which satisfy this relation from A to itself, A to A, right? So this was the solution to this question, and now let's do a summary of what we have learned today. Summary. So the first thing that we have learned today is the definition of a relation from binary relation from, let's say the sets are A and B, then the relation from A to B, right, is the relation from A to B is the subset, is a subset, is a subset uh, the relation from A to B is a subset of the Cartesian product of A and B. B, right? So we have a particular condition and we have to pick all the ordered pairs which satisfy the condition, right? So, like if we have greater than, if we have greater than condition and we pick the sets 2 3 4 and 1 2 3, and let's define from A to B. And now in this relation the elements, the ordered pairs that we get are 2 1, because 2 is greater than 1 and we are defining from A to B, and we cannot take 2 2 and 2 3. We can take 3 1 and 3 2, and we can take 4 1 4 2 4 3. So that is the relation from A to B given this condition. So that was about relation from A to another set B, and then we have discussed relation on a set, which is like defining a relation from A to itself. From A, let's suppose 2 3 4 to itself. It is clearly possible, right? Defining a relation from a set to itself. So that is all that we have learned today. Hope you enjoyed this video. Thank you very much.